Okay, this is just a different view that I found in a interesting article called "A Survey of Large Language Models." So it shows the various components or various steps to build a large language model. So I mentioned earlier, yeah, first you have to collect some data source, then you might need to filter the data, removing noise, removing outliers, removing obscenities, removing a number of things. Once you have cleaned the data, then you can start tokenization, meaning decomposing the text into words most of the time, or even into sentences or in byte pairs. So we'll see that later. To train a large language model, you need a sequence of words, or you can have also a sequence of byte pairs, which can be a part of a word, for example, or a sequence of sentences. Then once you have tokens, you need to convert all these tokens into embedding, so into vectors, because neural networks, they need vector as input, not just text. And then you need to add positional encoding, which means that if you have a very, very long text, it's not enough just to provide the model with the text, but it needs to know where are the individual words located in the text to understand. This is like you and me, right? If I would tell you a sentence with the words in a random order, you wouldn't understand anything, most probably, right? So the same thing. For large language model training, you need to tell the model where are the words, right? Where are they positioned in the sequence? Then after all this, you have to choose the large language model architecture. I will see that a bit later, encoder only, decoder, encoder, decoder. And then you have to choose what kind of training you want to do, depending on your use case. If you want to do word prediction, sentence prediction, mixture of experts. So mixture of experts is something that's been that is getting popular. I don't know if you heard about Mistral, the Mistral model, which is a mixture of experts. So basically, you train multiple models, then you give input to all these models, and then you choose. This is the wisdom of the crowd, right? You take multiple experts, and then you take an average of what the experts are telling you, and that should be the best possible answer that you can get. And then after you've done that, either you can use the pre-trained model as is, right, to generate text or to generate text or to do in-context learning, or you want to fine-tuning, right? And then subsequently, you can even reinforce the model accuracy, for example, using reference reinforcement learning, right? Okay. By the way, are you seeing my cursor? Just a quick question. I'm not sure you're seeing my cursor on the slide.
Yep.
Yep. Okay, cool. All right, thanks. Any questions so far? Okay, cool. Right. Now, on the same article, I found a high-level overview of almost all the popular LLMs. So this is interesting to see that one of the first LLM that's been developed was in 2018 by Google, called BERT, right? I think the article Transformer is all you need is from 2017, and Google came up with BERT that's been using the transformer architecture in 2018. And you see the number of parameters in BERT is 110 million. I would say only, right? Because if you look at Llama, for example, the latest Llama, you can have Llama 1 or Llama 2 can have up to 70 billion parameters. And so if you compare to 5 or 6 years ago, you had 110 million, and now you have 70 billion parameters. Now, if you go to the parent family, that's more like the Google family of large language models, you can have up to 540 billion parameters. This is just huge, right? Yeah, you're correct. You're correct. BERT is not. BERT is an encoder only model, which is not used for text generation, but more for classification. Yeah, that's correct. Basically, BERT will convert your input text into embeddings or a vector, and then you can use these vectors to predict, for example, a sentiment of a text or category of a text here. So, by the way, yeah, BERT is encoder only. That's what I was trying to say. And here you can see the Mistral 7B. So when you see a large language model followed by a digit and then a letter, it's usually to designate the number of parameters being used to train the model. So for example, you have also a Falcon 180B at the bottom, so it's 180 billion parameters. On the right-hand side, you can see the training data set used. So most of them have used online sources, Wikipedia, GitHub code for some of them, and so on and so forth. So quite interesting to